So I thought I'd do a question similar to the one you asked me about in Math Excel, and I'd do one of the ones out of the book that I asked you to do, and it's just like that question. So then that'll give you a chance to get that one right on your own. Okay. So this is from page 137, number 31. It was one of the recommended ones. They said, take this function y equals the cube root of 8x, and tell us what it is as a vertical stretch compression and what is as a horizontal stretching compression. So how do we do this? Well, we're going to look at this graphically, but let's talk a little bit about the algebra behind it. So I can, back in one of your earlier courses, you learned how to break down radicals, and I know if I have the cube root of 8 times x, I can break that down to the cube root of 8 times the cube root of x, and the cube root of 8, of course, is 2. So I can rewrite this function in this form, and what I'm seeing is this is just like having 2 times f of x. So this is a vertical stretch by a factor of 2, because it's outside the function, out in front of it. So it's growing faster, right? Instead of just with the coefficient 1, it's growing up by a factor of 2. If I wanted to talk about this as horizontal, well, it's taking whatever x I put into it, multiplying it by 8, and taking the cube root. So if we go look at a graph of this function, let's see, where did I do that? Right here, I got it out in Desmos. So let me turn some stuff off. So this is the cube root of x, and notice what it is. And so when x equals 1, y equals 1, and when x equals 8, y equals 2, and of course it's got all those decimal values in between. So if I graph the cube root of 8x, all that, notice it's 8's inside the function, so it's just the cube root of 8x. Look what's happening at 1. So here's the here you can see the vertical stretch really nicely, right? Yeah, x equals 2. So here's what, and then same thing, if we went out to let's see, this is 8. If we went out to, where do we want to go out to? Well, we could do it this way. Here's the normal cube root of x. See, when x equals 8, y equals 2, and that's happening all the way back down here at 1 for the stretch function. So what I want you to see, you can talk about this function two ways, the 8x. It's a vertical stretch by a factor of 2. Notice that's exactly the same function. And we did that with factoring out the cube root of 8 and taking the cube root. And this is also can be talked about as a horizontal compression by a factor of 8, because normally when x equals 8, y equals 2, and I'm doing that 8 times faster. It's happening way down here at 1. So that's why it's a horizontal compression. It's growing faster. Okay, so I hope that helps. And you've got a 216, and the one you shared with me. I don't know if you've gone to a different version, but think about what the cube root of 216 is, and that's going to help you. It might be hard to see it in the graph because 216 is way out there. What happens, so the other thing I wanted to point out to you, so hopefully that answers the question for that. But now, since you've got me recording, I want to do a little bit more than that. What about if they had given me the function written like this? Instead of 8x, the cube root of 1 over 8, or x over 8, which I can write as the cube root of 1/8 x. Well, if I take the cube root of 1/8, I get 1/2. So what I'm seeing here is this is a function that's been compressed vertically. It's only growing half as fast. So that means if this one were stretched vertically, compressed horizontally, this one is compressed vertically, stretched horizontally, and we can see that here. Let me turn these two on. So in order to get to 1, I have to go all the way out here to 8. So see how it's been stretched? Instead of being here, it's getting stretched all the way out to the 8. So that's a horizontal stretch. It's also a vertical compression, because look what's happening here. This is about, I don't know if I'll get it exactly. Oh yeah, I did. So when x equals 1, y is only a half instead of it should have been 1. So it's got a vertical compression by a factor of a half. Or you could say vertical compression by a factor of 2, knowing that compression means it's not growing as fast. And then same out here. That's a horizontal stretch by a factor of 8. All right, so you really just take a look at that. All right, and then I'll point this out to you on page, what page is this? This is page, what page is it? Here, I guess I gotta go over. Yeah, on page 134 of the textbook, they give us this stuff about horizontal stretches and shrinks. So I would think about this, if you write this as, if the number in front of the x is bigger than 1, it'll be let's see, how did they say this? I don't like what they're doing here. They're making you do some rewriting, and I think that really confuses the issue. I think if you do what I did here, rewrite it. If they give you x over 8, write it as 1/8 x. I think that'll help you see that if this is a fraction that's less than 1, it's going to be a horizontal stretch because it's taking longer to grow that far. And then this one, because this is bigger than 1, this is a horizontal compression because it's growing faster. And you can always help yourself out by rewriting these as a vertical by doing whatever the function is. We can almost always do that. Not always, but usually. Okay, so hopefully that answers your question and let you get that answer done. And if you're still stuck, give me a yell back and I can write it out and show you how to do that specific question.